Have a nice day, my dear student. Today we will discuss about back EMF of DC motor, which is the most important topic of electrical machine as well as basic electrical engineering. So let's start. Myself, Mr. Santanu Noskar, Assistant Professor of Electrical Department, GKCMJIS Group. These are my mail ID, santanu.uit@gmail.com, santanu.noskar_gkcm@jsgroup.org, and this is my Facebook page. You can like it, Being Electrify with Santanu. So let's start. What is back EMF? When the current carrying conductor placed in a magnetic field, the torque induced on the conductor, the torque rotates the conductor which cut the flux of the magnetic field. According to electromagnetic induction, when the conductor cuts the magnetic field, EMF induced in the conductor. The Fleming right-hand rule determines the direction of the induced EMF. According to Fleming right-hand rule, if we hold our thumb, middle finger and index finger of the right hand by an angle of 90 degree, then the index finger represents the direction of the magnetic field, the thumb shows the direction of motion of the conductor, and the middle finger represents the EMF induced on the conductor. On applying the right hand rule in the figure, it is seen that the direction of the induced EMF is opposite to the applied voltage. Thereby the EMF is known as counter EMF or back EMF. The back EMF develops in series with the applied voltage but opposite in direction. The back EMF opposes the current which causes it. The magnitude of back EMF is given by the expression here, EB equals to phi ZNP by 60A, where EB is the induced EMF of the motor known as back EMF, A is the number of parallel paths through the armature between the brushes of opposite polarity, P is the number of poles, N is the speed, J is the total number of conductor in the armature, and phi is the useful flux per pole. A simple conventional circuit diagram of the machine working as a motor shown in this diagram. In this case, the magnitude of the back EMF is always less than the applied voltage. Just go through this peak. The difference between the two is nearly equal when the motor runs under normal condition. The current induced on the motor because of the main supply, the relation between the main supply, back EMF and armature current is given as EB equals to V minus IAR. Now the advantage of back EMF in DC motor. The back EMF opposes the supply voltage. The supply voltage induces the current in the coil which rotates the armature. The electrical work required by the motor for causing the current against the back EMF is converted into the mechanical energy, and that energy is induced the armature of the conductor. Thus we can say that energy conversion in DC motor is possible only because of the back EMF. The mechanical energy induced in the motor is the product of the back EMF, and the armature current is EB IA. Number 2. The back EMF makes the DC motor self-regulating machine. The back EMF develops the armature current according to the need of the motor. The armature current of the motor is calculated as IA equals to V minus AB by RA. We can get this equation from this equation. Okay. So now the relation between mechanical power Pm, supply voltage Vt, and back EMF EB. Okay. So the back EMF in the DC motor is expressed as EB equals to Vt minus IARA, or EB equals to V minus IARA. So we can say here V equals to EB plus IARA, where EB is back EMF, IA armature current, V terminal voltage, RA resistance of the armature. Now the maximum power developed on the motor is expressed as Pm equals to VIA minus 2IA RA, On differentiating in above equation, we can get dPm by dIA equals to VIA minus 2IA RA equals to VIA minus 2IA RA equals to 0. So from here we can write V equals to 2 minus IARA, V by 2 equals to IARA. From the back EMF equation, we get V equals to EB plus IARA. Also we can say V equals to EB plus V by 2, or we can write V minus V2 equals to EV, and at the last V by 2 equals to EV. So from the above equations, so that the maximum power developed in the motor when the back EMF equals to the half of the supply voltage. So thank you. This is my Facebook page, Being Electrify with Santanu. You can like it, and this is my YouTube channel, Being Electrify. You can subscribe it. Thank you.